Good morning, Year 12 further mathematicians. I hope you're all well. Just going to continue with the same subsection as last time on partial fractions and integrating functions using partial fractions. There's one more complication that could happen. They could give you something called an improper partial fraction. That's when the highest power on the numerator is equal to or bigger than the highest power on the denominator. We've done these improper partial fractions in chapter 1, and for this you're going to have to use a combination of long division as well as partial fractions to help you integrate certain functions. So the key difference today is this improper part. So I'll say it again, the highest power on the numerator will be bigger than or equal to the highest power on the denominator, and that gives you the clue on using long division then partial fractions. So the question for today is this one. We're going to integrate this fraction, and again this is improper because the highest power on the numerator is 2, highest power on the denominator is 2, therefore this is an improper partial fraction. Now in an exam, to be fair, they probably would give you a clue by giving you a part A and asking you to write this fraction into a quotient and fractions as well. So it'll tell you to use partial fractions. But I'm going straight into it. So I'm doing everything in one step. So the first thing I would do is use long division. So I'm going to see how many times 9x squared minus 4 goes into this. Right. I prefer to fill in the gaps with 0x's rather than doing anything, rather than just missing them out altogether. And then 9x squared minus 3x plus 2 goes inside. And now long division. So the only thing you can do in long division is remove the first column. So 9x squared needs to go into 9x squared, and it goes in once. 9x squared. Remember, this part is when you do 1 times 9x squared plus 0x subtract 4 gives you 9x squared plus 0x minus 4, and then you subtract that. First column disappears, and you're left with a remainder of minus 3x plus 6. And in other words, 9x squared minus 3x plus 2 over 9x squared subtract 4 is identical to, right, that bit at the top has a name. It's called the quotient, how many times it goes in. And that bit at the end you're more familiar with, that's called the remainder, what's left over. So this would be equal to the quotient plus the remainder over what you were dividing by. And I was dividing by 9x squared subtract 4. Like that. So that's the first step, first of many. Okay, now what you have to do next in order to integrate this is, because if I try to integrate this entire thing, I can integrate 1, but I can't integrate this. I have to use partial fractions on this remainder that was left over. So I can do this bit, and I just need to focus on this bit. So all I'm going to do is focus just on that section there. So we've got minus 3x plus 6. 9x squared minus 4. Now, before I even write this, I noticed there's something wrong, because partial fractions, or any fractions in maths, algebraic ones, normally everything's factorized, and that denominator is definitely not factorized. So think about what that would factorize to. The first thing comes into my head is when I see a 9x squared and a 4 and a subtraction is the difference of 2 squares. So that would actually factorize to 3x minus 2, 3x plus 2. And now I'm ready to predict what this is going to be equal. So the partial fractions you would have for this would be a over 3x minus 2 and b over 3x plus 2. You want to work out what a and b are, so you have to actually write them as fractions. So this would be a, or as one fraction, 3x plus 2 plus b, 3x minus 2 over 3x minus 2, 3x plus 2. I'll write this in again. And then get rid of the denominators, and you're just left with the numerators. And again, this is an identity, so it has to work out for every single value of x. And if you select some very specific values of x's, this becomes a lot easier. So the best x values to pick would be x is equal to negative 2/3, and also x is equal to positive 2/3. Let's see what would happen. If you put negative 2/3 in, you get minus 3 minus 2/3 plus 6 is equal to, this term disappears, and you're just left with this term, which would be b brackets 3 minus 2/3 minus 2. Type that into calculator. No point doing anything in my head. If I've got a calculator, plus 6, okay, 8 equals, how many b's? 3 minus 2/3 minus 2 minus 4 b's to give you b is negative 2. Half of it done. Other half. Substitute 2/3 in now, you get minus 3 2/3 plus 6 is equal to, second term disappears now, and you're left with a 3 2/3 plus 2. Simplify that. Minus 3 positive 2/3 plus 6 gives you 4. And then 3 2/3 plus 2 gives you positive 4 to give you a is equal to 1. So now we've got the partial fractions. So that original thing there, we can now write out again. So that is 1 a over 3x minus 2, so plus 1 over 3x minus 2 plus b, which is minus 2 over 3x plus 2. And that is what that original thing there was. And we are integrating this with respect to x. And again, you can integrate these separately. Integrate 1 with respect to x. Integrate 1 over 3x minus 2 with respect to x. Minus integrate 2 over 3x plus 2 with respect to x. And 1 integrates to x. And there is a pattern to these, by the way. Some of you will know the rule of this goes to ln 3x minus 2. But then it's like the reverse chain rule. You have to divide by 3, so a third. Ln 3x minus 2. And this one, again, 2 ln 3x plus 2. But then reverse chain rule, you'd have to divide by 3. You could also use the guessing, try different functions, and then work out what you need to divide by. But after you've done a lot of these, you'll spot the pattern of dividing by stuff, etc. And remember the plus c. Job done. And that would be it. I want you to do a few more questions in that same exercise as last time. Now, so this is page 312, looking for improper partial fractions. So improper partial fractions would be question 5 and question 7. In those questions, you'll have to do some definite integration where you've got limits, but it's just an extra step. I would just continue, do everything up until this point, and then substitute the upper limit in, substitute the lower limit in, and go from there. And that would be it. Okay, so leave it with that. If you've got any questions about any of these, then let me know in the Teams chat. Remember to keep uploading your work to the class notebook, and I'll speak to you soon.